So let's say we have a nice simple function here, f of x equals x squared, and we want to find the slope of the tangent to f, that function, when x is equal to 2. It's worth taking a minute here to visualize what we're talking about here. So f of x equals x squared is just a parabola like that. When x is equal to 2, we're somewhere over here. So we're saying at this point, what is the slope of the tangent line? So a tangent line would look something like that. So it's a pretty steep tangent line. The function is pretty steep at that point. So that's the concept of what we're doing. The actual nuts and bolts in what we're doing is using that derivative formula. Okay, so this is just the sort of formula for a derivative. That's what was derived earlier. If we want to know specifically when x is equal to 2, then a is equal to 2, right? A is the x coordinate of the point we're interested in. So what we're going to do is we're going to substitute a as 2. So that is f prime of 2, or the derivative at 2. Okay, so does that help? Well, it doesn't seem like it, but we haven't really done anything specific with our function yet, right? We're writing it in general in terms of f of this thing here and f of 2. But remember, f is a function, and we can input things into that function. So what this really means is that 2 plus h is the input into the function f. And if the function is x squared, then that means we are squaring the input. So I'm going to rewrite the numerator by substituting 2 plus h into the function f of x. So that would be 2 plus h squared. Again, 2 plus h is just being used as the input into that function. As well, in the numerator we have a subtraction of f of 2. So that's nice and simple. All that means is we take 2 and we put it into the function, so 2 squared. Okay, so now we can start using our understanding of limits. This might seem a little bit difficult because you see you can't directly substitute 0 in for h, because then you get a 0 in the denominator. We don't like that. It's not defined, so we're going to have to do something different. That means we're going to have to try, I recommend simplifying in the top here. There's some algebra we can do in the top, and hopefully when we simplify it, it cleans up a little bit. So let's see. Well, this is just a binomial squared. So if I rewrite this thing squared, I get 4 plus 4h plus h squared, and then minus 2 squared is the same as minus 4. Okay, now might not look like we're getting somewhere, but we are, and I can see that because this 4 and this negative 4 will cancel each other out, and what we'll have left with in the numerator is 4h plus h squared. What's exciting about that is this term and this term both have a factor of h. So what that means is we can cancel the h in the denominator by canceling one factor of h from each of these. So this will cancel with this h, and it will cancel one of these h's. And if we simplify all of that, it simplifies very nicely to that. Okay, so now we're asking the question, as h goes to 0, what happens to 4 plus h? And now we can just do direct substitution, because if h is 0, we don't have any problems with the denominator being equal to 0 or anything like that, right? So we can do direct substitution. This is equal to 4 plus 0, which is equal to 4. Okay, so we did a whole bunch of weird algebra there. Just to remind you, what we just calculated is called f prime of 2. And what that represents is the slope of the tangent line. So the slope of the tangent line at x equals 2 is equal to 4. We are going to do one more example here. So we have a different function this time. F of x is equal to 2x squared minus x. And this time we want to know what is the slope of the tangent to f at the point where x is equal to 1. The hardest work we have to do here is up in the numerator. That's where all the fairly tricky algebra is. So we're going to substitute 1 for a, because that's the point that we're interested in. We want to know the derivative at 1. So we're doing f prime of 1. Okay, so that's not the hard part. All we did is substitute a 1 in for a. The hard part is now we have to use this h plus 1 as the input into our function. The function is here. This one's a little bit more complicated. So again, everywhere we see x, we have to use h plus 1 as the input. So I'm going to write that out. Instead of 2x squared, we have 2 times the input squared. So that's 2h plus 1 squared minus x. So minus, again, everywhere we see x, we have to replace that with h plus 1. So we have minus h plus 1. So that only takes care, and I can color code this a little bit. What I just put that blue box around is equivalent to that blue box. Minus f of 1 is a little bit easier because we just have to substitute 1 into the function. And if x is equal to 1, this calculation is pretty easy. It ends up being, well, 1. If you don't believe me, feel free to pause the video and calculate that, but I'm pretty sure that that equals 1. Okay, so we subtract 1 from that. So just to emphasize, that minus 1 comes from this purple box here, minus f of 1. That's where that has come from. Okay, and then in the bottom we just have h. So all that divided by h. Again, we have the same problem where there is an h in the denominator. We always have this problem where we cannot substitute 0. So what we have to do is do algebra in the top and then hope that we can cancel out that h. Okay, so we've got a considerable amount of algebra to do here. If I expand this bracket, I get 2 times h squared plus 2h plus 1 minus this term here. I guess I can expand that negative sign into the bracket. So that'd be minus h minus 1. And then we still have this negative 1 here, so subtract 1. Over h. Okay, I think I can move one step further down here, and then we'll have to start working to the right. So let's see. If I expand all of this bracket by multiplying the 2 here, 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 I get 2h squared plus 4h plus 2 minus, and then let's see, all of this stuff, well, that's minus h minus 2. And again, all that over h. Can't quite cancel it out yet, but I think we're getting close, because looky here, plus 2 and minus 2, those cancel each other out. Oh boy. And everything else in the numerator has got h's in it. So I can cancel from this h, I can cancel one of these, and I could cancel the h from that 4h, and I can also cancel this minus h here, so that just becomes minus 1. So if I simplify all of this, I end up with h plus 4 minus 1. And again, we are thinking about the limit as h approaches 0. I finally reached the step where I can substitute 0 in for h, because if I do that, I don't have to divide by 0 anywhere. So if I make h equal to 0, I end up with 0 plus 4 minus 1, which is equal to 3. Okay, so finally, just to interpret this answer, what this gives us is f prime of 1 equals 3, or in other words, when x is equal to 1, the slope of the tangent is 3.